this week's session, we're talking about, and by we, I mean Beta, because like I said, he knows everything. We're talking about using Spatial and GeoJSON, SDO Geometry with JSON in the database. And with all of that, I'll stop rambling and I'll let Beta take over and do his thing.
Thank you for the great introduction, Blaine. I know a bit about JSON and almost nothing about Spatial up to about a few days ago. Then I learned a bit, and that was actually quite exciting because there's a lot you can do in a pretty simple way. So let's get started. I will do a little bit of concepts, just a few slides. Let me just share my screen here. Blaine, can you see this?
Yes, I can.
Okay, wonderful. So let's see if I go to full screen mode. Okay. So what do we do in spatial support in Oracle? So this has been an option developed many years ago. Actually, Oracle 7 is what Google returned for spatial when I Googled for the first version. And obviously a lot of extensions has been made. And one of these extensions is the mapping of these spatial objects to JSON, specifically the GeoJSON format. And that's been done in 18.1. So already quite a while ago. So what are the common use cases? And obviously, you can imagine if it's developed since Oracle 7, it can do a lot. So I'm really looking only at the most basic use cases. And I'm not even sure what all possibilities exist. So one thing is you want to find out a distance between 2 points. Let's say you want to, you have 2 cities and you want to find out what's the distance between it. Another example could be you have a shape. For example, I tried to create a shape where the dimensions around Poland, I think my hand was a bit shaky. And we want to find out if a location or a GPS coordinate is inside of a specific region or country in this sense. So the green point is inside, the yellow is outside. The other example is if you have 2 shapes, so I put in the blue shape there that is not reflecting any country, but let's say that's the range of, I don't know, a radio signal, and you want to find out if these 2 shapes have an intersection or if they're contained. So these are typical problems. And just a very brief introduction to SDO Geometry. As I said, I'm relatively new to this as well. So you have different kinds of geometric types. The simplest one being a point, think of a GPS location, or you have a line which consists of different points which are connected, or you have a shape like a polygon that here is at the upper right. It's kind of a rectangular, but you can imagine if you have more of these coordinates, you can create a polygon around a country, for example. And if we look at GeoJSON, this is an RFC that's been around quite a while, several years, and it's a proposed standard by the IETF. You can find out more if you go to geojson.org. So this is nothing that Oracle controls or even is really involved in. But the nice thing I found out is that the GeoJSON object types, point, multi-point, line string, polygon, etc., map very nicely to our SDO type. So I'm not sure why that's the case. As I said, I'm not an expert. It might be that there is some spatial standardization committee which has said you need to have polygons and line string, or if it's just an obvious way. But the nice thing here is that SDO and GeoJSON are quite interchangeable, meaning if you have one instance, you can easily convert it to the other. Let's look at one example here, and this is the last slide, then we jump at actual examples. So this is an example of GeoJSON. So here we see that our GeoJSON, we look at this geometry thing. Basically, it's a JSON object. It says I'm a point, and then it has the coordinates and 2 values inside. One of them is the latitude, the other one is the longitude. And the nice thing about GeoJSON, it's not only spatial information, but you can have additional properties inside here. So here we have prop 0. So this could be, for example, country equals USA. If this was not just one point, but let's say this was the polygon that surrounds the map of the United States. So this is the introduction, the concept. So we want to play with SDO Geometry and GeoJSON. Since I work with some large data, I didn't use Live SQL this time because I'm actually using data that I'm downloaded from the internet, because it's more fun if you work with real data, and for that you just need more of the spatial information. It's not so much fun if you say, hey, this is a GeoJSON, and then you do this, and now you have an SDO, and vice versa. So the first thing I downloaded was from a marine traffic website. This is a API where you can pay money and then you can track ships. Apparently that is, if you own a fleet of boats, apparently it's public information where they are. And that provider offered some little free data, so I didn't pay for it, and I was able to get a bit of JSON from this API. So let's create our staging table here, and we just load it from the file system. And so now let's see how big the data is that they provide to people for free. So I downloaded a 3.8 megabyte document. By the way, if you have any question, just write it in the chat and Blaine will read it to me. So today's presentation is not so long, so we can definitely ask question and just interrupt me while I'm at it. So we have a 3.8 megabyte.
There's a Q&A button at the bottom. If you put your questions there, it'll keep it a little bit more organized. So sometimes I lose track of questions if the chat gets active. So just hit the button that says Q&A if you have a question.
Right. So the one thing is, if you work with public data, you just don't download it from somewhere and you have a few kilobytes, megabytes, gigabyte of data. You can obviously look at it. So we do a select column from stage and we see, oh, this is just some JSON data. I can tell that by looking at it. But it's really hard to understand what's going on. I could obviously select, I see here that the first character is a square bracket. That's indicating that's an array. So it's probably a collection of something. So I can use our JSON query and I say $0 to access the first element. I could copy this out and let's say I use JSON lint. People who join more often know that I'm a big fan of JSON lint. So I just copied it here and pressed validate JSON, and it's not only validating it, it's also pretty printing it. So we see we have some data about some date field, some latitude, longitude looks like. There is a vessel name. Vessel is ship. They call them vessel. And some other information that I don't know what it really is, and I don't need to know it. So this gives me some understanding, but since it's JSON, how do I know that just looking at the first object of an array has all the fields that I really can encounter? There might be fields which are optional. So what we do, we obviously use the JSON data guide. I've used this several times, so I'm not giving a full explanation. I'm just saying we're sampling the entire data set and we generate a schema. And the schema inside tells us that we have an array. And inside that array, we have objects, and there is a field called type. It's a number. No, there's a field called COG. It's a number, and there is latitude, longitude numbers, and probably somewhere there's also vessel name. Or vessel type, vessel name, there it is, and that is a string. So very easily, I get a summary of my entire data set in 88 pretty printed lines here. I don't have to look at the entire 3.8 or 3 something megabyte to look at it. Well, the next nice thing is I can use this data guide to create a view. So in order to access the data, I have to write queries. Well, I'm a bit lazy today, so I write this little PL SQL procedure. I define a variable DG, it's a CLOB. I run the exact same query that I just ran, which gives me the data guide, but I just do a select into this variable, and then I call this procedure dbms JSON create view. I want the view to be called tracking view or tracking v, and it's a view on top of my staging table, and the JSON column was called call. So I have the views created. I can describe it, and you see here I have a relational view on top of my JSON data. Very easy. So let's do a count that we know how many of these tracking or GPS coordinates we have. And we see that this API gave me a little over 10,000 of these GPS tracking for the ships. I could also say, well, what are all the ships' names that I got? Select distinct vessel name, and I get about 45 of these boat names. There is this base state, and I use this to for ordering. It's the ISO date format, which is quite nice because I don't have to convert it to a date type. I can just do an order on the string basic here, or on the string ordering gives me the same as the date ordering. So I can see that for my vessel early dawn, I see this was the time and this was the longitude and the latitude that I got for this position. So now I can construct a spatial representation of this coordinate, and that is where SDO geometry comes into play. So I have a SDO geometry type. In this case, it's a point, and point is 2001. I think that is extremely intuitive, that a point is 2001. If this was like a polygon or something else, there would be a different number there. So you need to do a little Googling. It doesn't take too long to find it in the doc how you create the corresponding SDO geometry for a GPS point. So now this 4326, that is the coordinate system or the spatial reference system. This has something to do what these coordinates mean. I couldn't really quite understand it. I didn't spend too much time reading it. I also played with different coordinate systems. For my example here, it didn't seem to make much of a difference, but that is certainly something you need to read a bit if you want to work with spatial. And then we do create this type here, and I provide the longitude and the latitude. There are some optional parameters which are all null, and immediately I have a corresponding SDO geometry type. So now what do I do with it? Well, one example I figured out was we want to find out the distance of that ship that it traveled. So I need to know so basically if we go back to the more human readable format, here we have these dates. It's ordered by date, and we see that it jumps from one GPS coordinate to the next. So if we have these 2 points, we could calculate the distance between each of them. So I used this lag over SQL construct to get a previous position. So I'm selecting the time and the longitude and the latitude, and then the previous one. So the previous longitude and the previous latitude, and previous means order by the base date. So given the ordering of the date or of the timestamp, I can find the previous one. So if we do this, I get for each of these records, the first one has nulls for the previous one because there is no previous, but for any subsequent one, I find that the previous or the value for previous longitude is the one that's the longitude of the previous row. I think this makes quite sense. Not sure if I explained it the best, but I think everyone gets it. So now what we can do is we just take this query here and we use it in the with clause. So with the with clause, I can just use a query as a subquery. So I take this exact same query and I say, I call this now my tracking V or my travel info. So travel info is this subquery. And then I create a point for the longitude and the latitude and another point for the previous one. So I have 2 points for each of these data, and then I can calculate the distance between them. So I call SDO geometry the distance, give it 2 points. There is some optional unit argument. I figured out meters, could also have used kilometers or miles. So let's run this here. And we get distances in meters between these points. So this is around every 300 something meters. Then it sends another GPS coordinates. I figure these boats, they're probably not very fast. So I don't know, maybe it's once a minute or so, every other minute that they send some GPS coordinate. So now we have a bunch of these deltas. They're always around 300. So it seems this boat is cruising at, well, there's a bigger one here. Maybe some of these signals were not picked up. But let's say we want to find out what the maximum distance is, or the total distance that the boat has traveled. Well, it's quite easy. I just take the same query, but instead of listing every individual or partial distance, I just do a sum on top of this. So this is just a slight modification of the query. And I immediately know that this ship has traveled 1,090 kilometers. So I changed the unit here to kilometers, and otherwise the value for meters would be larger. Good. So this was an example where you have latitude, longitude information inside your JSON data, but it was not really GeoJSON yet. So it's some of the JSON data you get uses GeoJSON, some of the data does not. This was an example of data that did not use GeoJSON. This is why you had to create these constructs manually. So you had to invoke a constructor, SDO Geometry, to create these points. So now GeoJSON makes it a little easier. I've used Twitter, because Twitter has, some of the tweets have geolocations in them. So I picked an old data set from Twitter. So I created a table called Twitter, and this has the tweet inside, and I loaded it using external table. I don't load it right now because it's pretty big and it takes a while. I run this on a Docker image on my Oracle 20 version, but all of this is doesn't need 20 or 19, it should work on 18. So let's see if we look at our tweets, the data set I inserted, I have a less than 140,000 tweets. Well, this sounds quite moderate. Why didn't I want to load it? Because if we look at the size, it's actually 400 megabytes. So these tweets are pretty big. So what do? We, if they're so big, let's not even bother looking at the data. Let's just create the data guide. So I'm now scanning these 400 megabytes. And you see it doesn't take forever. Actually, the fan of my laptop is quite loud now. So my machine has to do a lot. So you, at the bottom here, all the 4 cores are maxed out. So we're scanning now. And now I get the summary of 400 megabyte. Let's go to the great JSON lint and validate it. So it is 2,066 lines long, so it is not small. So there are a lot of fields in a tweet. So for example, there's ID, there's geo, and this is one of the mistakes I made. I looked at the data guide and said, oh, there is geo, and this is actually properties, and it has types. This must be a GeoJSON, it has coordinates, and it's actually correct. It looks like GeoJSON, so I picked it. But there is another field at line 600 here, which is called coordinates. It looks the same, it has the same structure, and that's the one we want to use. We want to use coordinates. We don't want to use the geo field, and I'm going to tell you in a second why that's the case. So these are all the tweets I have. And I can look at the geo field. This is the one which I used first. And we see that a lot of the fields, actually all of them, don't really have a geo field. So it seems to be sparsely used. So let's add a word clause where this geo field is not null. And we get now tweets back with have spatial information. And you see here, this is our field geo. And it has type is point, coordinates, is this array of value? Perfect, I'm gonna use it. Well, there is one problem. And the problem that's there appears to be not really limited to Twitter, but a general problem of some GeoJSON data that I found, or generally data that is not fully self-descriptive. If you have longitude and latitude inside your array, the order doesn't matter. And what happens is that GeoJSON uses, now I have to look, oh yeah, I've put it here. So basically, the GeoJSON standard or definition says that the longitude comes before the latitude. And this is what happens in the coordinates value. So you see here, the minus 118 is the first item of this array, and it's the second one here. So geo and coordinates have the same data, but the array values are exchanged. Their order is exchanged. So this derailed me actually for an hour because I wanted to calculate distances, and nothing really matched up. But if you confuse longitude and latitude, you end up at a totally different place on Earth, and the distances you get don't really make a lot of sense. So I lost at least an hour on this one, and then when I found it out, I actually saw other examples which didn't have it right. So this is kind of the first lesson. If you work with GeoJSON, really make sure that the data is correct. There is nothing that guarantees it. You can't run, I don't know, schema validator or anything. These are just two numbers, and it appears that a lot of public data is generated from the same source. So they may start with a CSV or some database entries, and then if whatever conversion tool is not written correctly, you may end up with this data. And this is actually, Twitter has changed it since. So this is an old data set. So I guess if you download Twitter data today, they fixed it. But I was too lazy. I used my old data set and looked at the API documentation, and that was not exactly correct.
We have a question, Beta. It says, if we maintain large data in JSON format, any known performance issues while joining the view create on JSON data with other tables?
Let's postpone this to the end because it's a kind of a broader question that's not that specific to spatial. We can you remind me at the end that we discussed it?
Yeah, so this is the first time I've actually run a webinar with the new format. So I'm going to, I believe in the questions, there's a way for the person who asked it to mark it as answered. So don't mark your question as answered when we get to the end.
Exactly. Yeah.
Do it that way. So if anyone else asks a question,
it's a great question, but performance question can always lead to many options, and then we lose a lot of people. Let's get the let's stay focused on spatial for now, and spatial questions are fine as long as I can answer them. The other interesting thing that I found out is that there seems to be no ordering of longitude, latitude specifically. So GeoJSON uses one, but if you want to put it into Google Maps, you have to do latitude, longitude. So it's quite confusing, or at least maybe if you work a lot with spatial data, it gets easier, but I found it a bit confusing. Good. So how do we convert from GeoJSON to SDO Geometry? Well, there is a utility function here, SDO util from JSON. So we don't have to explicitly construct using an SDO constructor and put the longitude and latitude at the right place. Instead, we just call SDO util from JSON, and we have our SDO Geometry. This is a utility function. So what's happening here? We are extracting this coordinates value, or this coordinates array. It's then getting serialized back into a string, and we feed it into this utility function, which needs to parse it again. If we don't want to do the intermediate result generation of this array, we could also return straight from JSON value. So here we say JSON value. This is my tweet, my message. I go to the coordinates array and I say, well, returning SDO Geometry, and I get the very same results back. It's hard to tell because here SQL developer only tell us this is an SDO Geometry. It doesn't tell us what's inside, so they all look the same in the results here. Good. So now, what do we have so far? We are able to extract a coordinate or a GPS location from a tweet. So I pulled out a second map, and this is the map of the United States. This was also GeoJSON. So let's create this table here, US states. So I give it just a map. This is where I insert the GeoJSON into. Let's commit it. Now if we select it, we see it's type feature collection, blah, blah, blah. I save you running the data guide. I mean, obviously you could do this, but we see here, or I saw that this features looks like an array. And basically the first character is the curly braces indicating this is an object, or actually let's copy this into LifeSQL. We have enough time. This is the thing, and we have features is an array, and inside we have a multi-polygon, so not a single point. Obviously a country is, well, you could probably get the center of a state with one point, but here we actually have the borders of states as multiple points. And somewhere at the end, it says this polygon is called Nevada. Well, let's go all the way to the bottom. See here, it says this is Wisconsin. So it uses this properties field to put additional information in it. One of them is the name. So this array on top, or this array of coordinates, is actually reflecting the boundaries of Wisconsin. So okay, we have an array of array, and it's all JSON. So what do? This almost shouts like JSON table. So let's run it. We extract the contents of features. This is the topmost array we identified, and we see there is a bunch of rows, 52 rows. And aren't there 50 states? I don't know how 51 states. Let's take a look in a second. And each of them has this polygon. So let's get the GeoJSON off it. So what I'm doing here, I run the JSON table on the same row producing pattern. So for every feature, I extract a row. But then instead of printing the entire contents of the array as one row, like I did here, it said it's a JSON and a CLOB. I now extract out the column name. So I say the geometry field, I want this as a CLOB, and the name, I want to get it from properties.name. That's the one I showed you in when we looked at the JSON data. And now I see that Alaska has this textual information. And I also put the length in here. So you can see that bigger state, and especially states with more complex outlines or borders, which are not like rectangulars, need more information to define the polygon. And I think the simplest one was, District of Columbia and Utah. So they probably have a lot of lines as borders, so you need only 2 points to cover hundreds of miles, but with Alaska, you need pretty complex polygon. So this is still the GeoJSON data as a textual representation, but we want to work with it as an SDO. So what do? We replace this CLOB format JSON just with SDO Geometry. So JSON table can return SDO Geometry directly. Now if I run this query here, we see that we get the polygon back as one object. And since we have this polygon, I also put this function here. Well, give me the area. What's the square miles in this case of this polygon? And we see this as a result. So it's very easy to get this basic information. I have the borders of a state. What is it, the size? That's very easy to find out. The issue here is that if we want to repeatedly query this data, we want to avoid that this SDO geometry object has to be produced repeatedly from the GeoJSON. So if we create these spatial objects, that is a bit costly because we have to parse the JSON, we have to build up the corresponding SDO geometry, allocate memory for these points. So we want to materialize it. So all I do is I say, well, there's a table called states, and that is just create tables as same query as above. So now I have my states table. It has the name of the state and the corresponding boundaries as a polygon in SDO Geometry. So what do we have now? We have a map of the United States, and we have tweets with geolocation. So let's just find out the state for each tweet. So for this, I'm altering my Twitter table and I add another field to it, which is SDO Geometry. Again, I don't want to compute these SDO types all the time because this is expensive. And you can see how expensive it is right now if I run this, this will take a few seconds. So I run this JSON value, I extract this coordinates fields. Remember, it's 400 megabytes of data. So I have to look at every row, see if it has a coordinates, then extract the array, build the SDO, write it back. So again, you see I'm not using the SDO util function, but I'm using JSON value here with the returning SDO geometry type. So yeah, my laptop is not the fastest, and this also runs on Docker on my machine. So it'll terminate. Any questions, Blaine? Any additional ones?
Nope, just that one so far.
Okay, good. Okay, so it updated 137,000 rows. Let's commit it. And now let's find the tweet with the state info, or with the name of the state where the tweet comes from. And the tweets are from the entire globe. So they're not limited to tweets made in the United States. So I'm using the SDO contains operator. So first of all, I select from my Twitter table and my states table, I do a join. And the join condition is that the state, or that the coordinate is contained in a state. So I'm using SDO contains as an operator. And this basically has to be true. So if either well, we're also filtering here that the Twitter coordinate has to be there, but if there's a tweet outside the US, then the contains would be false. So we are running this, and it'll take a while, 3, 4, 5 seconds, I guess. And we now get back the tweets that are, or for every tweet, we get back the location.
Got 2 questions.
Yes.
One of the Q&A sections says, what happens when one of the rows cannot be converted into an SDO geometry object?
JSON value's default is to return a null value. So the default is so here the implicit, or the default is null on error, but you could say error on error, and then the error should be presented. I didn't run into this, so all the data I found in the internet, I mean, I played with more data sets. I didn't run into this, so I can't really answer if the error you get back is very meaningful. It may just say that data conversion or SDO construction failed, but it may not tell you why it failed, that the format is invalid or something like this.
And then there's another question from the chat. So by the way, like I said, I haven't tried this Q&A feature yet. So if that answers your question, I believe there's a thing where you can mark your question as answered. If you could try that for me, just so I know how the interface works. But the other question is, can you publish the demo in a live SQL script, even if the files themselves are not available? Yeah, I definitely plan to do that. I just have to think about inserting a bit of meaningful data, that there's at least 2, 3 rows, yes. But it wouldn't be fun if I only had 4 rows. I mean, this is really showing that's possible on real data, up to hundreds of megabytes on my little laptop here. Okay, so let's get back here. So we see that this operation took 9.24 seconds, so it's not very fast. So let's create a spatial index here. So I'm creating an index on my states. And the index here is not a B-tree index or a hash index, or I don't know what other known indexes you may think of. This is called the R index under the cover, or at least the R index is part of that.
And that is basically, in a simplistic view, putting a boundary box around a spatial object. So imagine you have a state of Alaska, which had like all these little boundaries laid out. Just think you have put like a box around it, and then it's very fast to pre-filter if a point could be inside it or not. So this is how the spatial index, or one of the methods how the spatial index improves the query performance. One thing you need to do, so I just clicked create index and it worked. If you just do that, you will typically get some sort of an error because it doesn't know how to create the index. So there is a metadata table where you have to insert something into. So you have to say, so my states table has, which has spatial data. You have to, if I understand it correctly, you have to give it some sort of this SRD spatial coordinate system information. So if you call create index, it's looking up this metadata view, and there needs to be an entry for this. So if I hadn't created the index before, I would have to run this insert statement here. Okay, so now we have the index. Remember, before it took about 9 seconds to complete. Now we run the very same query and it takes 0.2 seconds. And this is because these bounding box around the states just makes it so much faster to think to check out if a point is inside it or not. Good. So now, just for fun, if we have this, I can obviously do some stupid analytics. I can say, well, count me all the tweets per state, which are the states which have the most tweets, and we see California is 46, followed by Texas. And now I could normalize it by the state size, or if I had an additional data set by the state's population. But I think you see the message here that it's quite easy to work with spatial data. So almost at the end, so the lessons I took was there's a lot of spatial data out there. There's open data initiatives which publish data in various formats, one of them GeoJSON, but you better check it. The one thing I ran into is this latitude, longitude being not in the correct order, and I ran into that at least in 2 data sets. The other message, or the other lesson I learned, is like avoid the multiple or the repeated creation of the same spatial object over and over again for if you want to run a slightly modified version of a query. Just materialize it, add a column or materialized view, and you see it's much faster, and also use the spatial index. So now the last thing, last but not least, so what I've shown you is coming from JSON, go into the great spatial world of SDO geometry. Well, can you get out of it? Yes, you can. So this utility function also has a toJSON function. So let's say you have, or let's say you had a spatial application built on Oracle, so you're familiar with SDO geometry. Now you want to export the data. Well, it's quite simple. You use this utility function SDO util to JSON, you give it the SDO type, and it will just serialize it into a JSON representation in GeoJSON format. So now you could send this to another application, or send it to a client which uses this to put a point on the map or to draw a map. So it is quite easy to go to work with GeoJSON and SDO together. So that was my little show here. I actually like this one a lot because I learned quite a bit. Now let's go to the question. Blaine.
So there's still that same question there. If you click the, I think the Q&A button for you should be at the top of your screen.
Okay, let me stop sharing my screen. Where is, oh, it's here. Stop sharing. Okay, now.
At the bottom, you should see a Q&A button with a big red 1 on it.
Okay, I got it. Yes, I got Q&A, and there is the chat. I see the chat. I see the panel list. Where is the, oh, it opens a different window. Yeah, I got multiple monitors, and it puts these windows always on a different monitor, and I have to look at it. If we maintain large data in JSON format, any known performance issues while joining the view created on JSON data with other tables? So The question is really, if you join the view, I would say there are at least two use cases. One is it's used for reporting, and you basically join all the rows, or you need all the rows in your JSON to create a longer report. Then that is one use case. The other use case, if you look at a specific field in the JSON, let's say there is a join condition, then you obviously want to put an index on it, or you want to put a functional index on one of the columns or one of the fields in the JSON, so that the optimizer picks up the index for that. The question is now, what do you mean with large? We had customers who use this for very large amounts of data, and it's either the index route, or we also have customers which use massive reporting out of JSON. Then typically the work has to be done. It's a full table scan. Also on the JSON, every row gets put into JSON table and outputted, and it goes into some sort of reporting scheme. There's always the point if you have, so JSON table will always involve the parsing of the JSON, which is slower than a regular table. So if you have, the other possibility would be to say you create a materialized view. Then you basically get the same output from the view. It's just faster because it's materialized similarly to a table. So it does not need to parse the JSON data. And you can use the fast refresh option, meaning if one of the JSON changes, or if you have a new JSON record, it's just computing the materialization of that new or updated row. So this is kind of standard tuning, I would call that. So if you know how to tune joins in general, or work with materialized views, all that, I think that's mostly, or all of that applies to JSON as well. So I mean, this was a generic question. I think I gave a generic answer. If you have more specifics in mind, then feel free to add that to your question.